Welcome back to The Explainer. I am absolutely thrilled to have you here today because we're diving into a genuinely fascinating subject: how selective breeding fundamentally improves livestock. When we look at modern agriculture, we aren't just looking at random animals grazing in a field. We're actually looking at generations of incredible, highly targeted biological engineering. Farmers and agricultural scientists use selective breeding to engineer animals for very specific purposes. And today we're going to unpack exactly how form follows function in the animal kingdom.
Okay, let's dive right into this. Here is our roadmap for the farm tour today. We're going to quickly cover the basics of livestock breeding, then move on to cattle, specifically meat versus milk. Check out targeted traits in goats and swine. Look at poultry specialization, and finally, zoom out to see the overall impact of selective breeding.
All right, kicking things off with Section 1, the basics of livestock breeding.
Before we get into the really wild examples, we need to master our vocabulary. So, first up, what exactly is livestock? Well, livestock refers to domesticated farm animals raised specifically for human use. These aren't wild animals and, they definitely aren't household pets. They are an integral part of agriculture that provides us with our food, like meat, milk, and eggs, our labor, and essential raw materials like fur, leather, and wool. This definition really sets the stage for the massive variety of animals we're going to cover today.
Next up, we have breeds. Now, it is absolutely crucial to understand that a breed isn't just about how an animal looks. It's more like a specific biological toolkit designed for a distinct purpose. A breed is a group of animals sharing similar traits that have been carefully, deliberately chosen over time. Why? Well, to improve overall production, to adapt to specific and sometimes super harsh environments, and ultimately to yield better quality products.
Which naturally brings us to actual breeding. Breeding is the intentional mechanism farmers use to improve stock quality over generations. It's the active, hands-on process of producing improved livestock through highly calculated systems. Whether that's inbreeding, crossbreeding, line breeding, or outbreeding, the end goal is always exactly the same: to increase production and improve the quality of the animal.
Now, what's really interesting about this slide, just a fun little piece of agricultural trivia before we move on to the actual breeds, is the unique terminology used for groups of these animals. If you got a group of swine, you actually have a drove or a drift. Cattle and goats, they hang out in a herd. Rabbits form a colony, chickens gather in a flock or brood, and quails group together in a bevy or covey. Just a cool reminder of the distinct identity each of these groups holds in the agricultural world.
Moving right along to Section 2, cattle, specifically meat versus milk.
This is our first major stop on the tour, and this is where we clearly see how selective breeding guides animals down two totally different, highly specialized paths. Looking at this comparison, the contrast is stark. Over on the left, we've got dairy cattle, engineered entirely for milk output, but it goes deeper than just making milk. The black and white Friesian is bred for huge volume. The Irishshire is bred for unusually high protein milk, and that small light brown Jersey favored because its milk has a super high fat content. Contrast that with the right side, beef cattle. Breeds like the red and white faced Hereford and the black Angus are strictly utilized for beef. They aren't trying to produce milk. Their biology is 100% dedicated to building muscle. Form literally follows function here.
But wait, it's not actually just about food. Some breeds serve totally different, highly specialized roles. For instance, the red-colored Devon breed is kept primarily as strong working cattle. They provide literal horsepower, or I guess cattle power, to a farm. Meanwhile, the red and white Simmental is highly prized for its genetics and used heavily in crossbreeding systems just to improve the overall quality of a mixed herd. All right, let's head into Section 3, goats and swine. Targeted traits.
And this brilliantly illustrates that this strict biological specialization isn't just for massive animals like cattle. We see the exact same meat versus milk divide in goats. On the left are milk producers. The white or cream-colored Saanen is actually the largest milk-producing goat breed out there. You've also got the Nubian with those long ears and the La Mancha with its super short ears, all optimized for dairy. Now check out the right, meat goats. The Spanish boar and the hardy Kiko aren't focused on milk at all. They've been meticulously engineered for rapid weight gain and incredibly fast growth rates. They turn feed into meat with just astonishing efficiency.
Now, I want you to think about this for a second. We've talked a ton about food production so far, but what if you don't actually want milk or meat from your livestock? What else can selective breeding optimize?
Well, the answer is fiber. Selective breeding caters brilliantly to the textile industry as well. A perfect example is the Angora goat. It's got a small, slender body and isn't raised for food at all.
It's specialized solely for producing mohair fiber. And over in the rabbit colony, the Angora rabbit has been bred specifically to produce long, incredibly soft Angora wool. It's a massive testament to how flexible and targeted breeding can actually be.
Now let's look at swine, because the targeted traits here become incredibly granular. I mean, all swine are raised for meat, sure, but look at the subspecialties. On the left, we have bacon-type swine. The American Yorkshire, the large white, and the landrace, which you can easily spot by those droopy ears, are explicitly bred to be bacon-producing machines. On the right, we've got pigs bred for totally different meat profiles. The black and white Hampshire gives you lean meat. The Duroc Jersey is optimized for rapid growth, while the middle white breed is actually targeted specifically for its excellent flavor. Selective breeding lets farmers dictate not just that they get pork, but exactly what kind of pork they get.
All right, jumping right into Section 4, Poultry, Eggs and Meat.
If you want to see some of the absolute most mind-blowing examples of targeted breeding, look at the physical differences here in poultry. On the left, the egg layers. The Leghorn, originally from Italy, and the Ancona breed are literal biological egg-laying machines. Their physical frames are incredibly light because they channel almost all of their caloric energy into producing eggs. On the right side, the meat producers. The Cornish chicken is a heavy-bodied bird. It is fundamentally different in its very design from a lightweight Leghorn because it uses its energy to build significant body mass.
I just want to pause on this number right here. 300. That is the number of eggs that highly specialized layers, like the Australobe chicken and the Cocky Campbell duck, can produce in a single year. Really think about that for a second. Through careful selective breeding, farmers have optimized these birds to lay an egg almost literally every single day of the year. It is a staggering achievement when you think about agricultural productivity.
And this whole concept stretches right across the entire bird family. Specialized ducks, like the Peking, are bred to grow incredibly fast just to yield high-quality meat. Looking at quails, the tuxedo quail is kept specifically for its high egg production, while dual-purpose breeds, like the Japanese Seattle, provide a solid balance of both eggs and meat. The rules of meat versus egg specialization apply universally across the board.
Which brings us to our final stop, Section 5, the impact of selective breeding.
So, the crucial point is, why does all this matter to us? Well, it essentially comes down to building a robust foundation for our entire society. Selective breeding drastically improves overall food production and efficiency. By raising improved breeds, less feed and resources are wasted, and that provides vast employment opportunities across the entire agricultural sector. For the farmers, having reliable, specialized livestock seriously increases their economic stability and income. And for you and me, the consumers, it ensures a consistent, high-quality supply of meat, milk, eggs, well, the whole shebang. Optimized livestock are quite literally the backbone of our economy and our daily food supply.
Which leads us with one final, pretty massive question. We've seen today just how specific and powerful selective breeding can be, right? Literally transforming animals to perfectly fit our needs, like engineering a single bird to lay over 300 eggs in a year. So as our understanding of biology and genetics continues to grow, how far can we push the boundaries of agricultural productivity in the future? It's a wild thought, and one that's definitely going to shape the future of our food supply. Thank you so much for joining me for this explainer. Keep asking those great questions, and I'll see you next time.